video we discussed about the basic of the thermodynamics, that why do we need to study this subject, and how it will help us in our daily life, day-to-day lives and engineering application. Now today I am going to discuss about the basics of thermodynamics. That is that point that needs to be focused while we study the thermodynamics. So here, 1 minute, let me pick the pens. So here we start the basics of thermodynamics. Basics of thermodynamics. So the point we will discuss here one by one. Let me write down it at first. First, macroscopic versus microscopic study. Second, thermodynamic systems and control volume. Third, thermodynamics properties. Processes and cycle. Fourth, concept of continuum. Fifth, thermodynamics, that is state postulate. That is related to the study of pure substance. Sixth, thermodynamics equilibrium. So start the points which I have discussed earlier. Now that the topic is the macroscopic versus microscopic study. Here, in real world, we can analyze any system in the two ways, in the microscopic and macroscopic. In macroscopic, we disregard the behavior of individual molecules, but in microscopic we have to consider all the in behavior of individual molecule and take the summation of them to take the net effect on the to get the net effects. So now suppose let us consider a container contains some amount of gas. Gas molecules, that is red dots represent the gas molecules. So we attach here a pressure gauge and a thermometer to measure the temperature. So here we get certain values in the pressure gauge and certain value in the temperature scale. So now here when we get the result here in the pressure gauge and the temperature scale, that result does not take the individual molecular effect, but rather it takes the net effect of the molecules present in the system. But while we study in the microscopic analysis, we have to consider each and every individual molecules and their effect. And suppose that each and every molecule in the container has a different velocity, different positions, and also different mass. So if we want to take the pressures from the microscopic point of view, then we have to get the summation of the momentum change, rate of change of momentum, and their effect on the per unit area. So we can get the same result from the microscopic point of view also. So in the rarefied gas technologies, in the rocket science, we use the microscopic, but in the normal analysis, means our point of study basically focused on the now application. In macroscopic study focuses on the normal thermodynamic study. Means this is called the classical thermodynamics study, which is our point of interest. Classical thermodynamics. This is our point of interest. But while in microscopic analysis focuses on microscopic studies used in rarefied gas theory. Rarefied gas theory, etc. In many other applications we can use microscopy, but in our scope of study we only focuses on that macroscopic. Point of our discussion is the thermodynamic system and control volume. Thermodynamics system and control volume. So now here in thermodynamic system we consider a fixed amount of mass in space, and anything outside the mass is the surroundings. So there is an interaction between the system of fixed mass of quantity and the surroundings in terms of heat, mostly in terms of heat, and it has a control surface that may be flexible. And another type of system is the control volume, that is fixed quantity of resin is assumed in space, and anything outside this is the surrounding. So here in control volume may interact with the surrounding in mass and energy. Here energy means energy comes heat, work, anything else. So here also the control, its surface is known as control surface, and control surface may be fixed may be movable, but application of this is in real life application, that is turbine, compressor. When we analyze this turbine, compressor, heat exchanger, then we go for uh, control volume approach. And here only this is also considered as a closed system analysis. This can be both closed and open system analysis. Okay, and here one thing is that if there is no interaction between the systems of interest and the surroundings, then that system is called an isolated system. That is also an important thing. Isolated system. That is also an important thing that is come in the second law when we study second law of thermodynamics. Okay, so in isolated, and another thing is that another interesting thing I want to study here, that is piston cylinder device. Third, what the category of the piston cylinder device, in which category should it fall? If we think about the piston cylinder device here, that contain a fixed quantity of gas. So if we think about this, then what kind of system approach is this a control volume approach, or this is a system approach? What should be it here? This answer in the comment, and it will be very useful if we get some interaction from your side. So now about the next topic, that is thermodynamic properties and process cycle. So here we assume that a particular system, the physical behavior of a system can be described with the help of certain parameter that is macroscopic in nature, that is temperature, pressure, volume. These are required to describe the system, and these are called the properties. These are called the properties of the system. Now when these properties takes a definite value, then we tell the system exists in particular state. So now when there is a change of state occur, then the system properties takes the new value in the second state. So if succession of the changes of state are joined, if the succession of change of state is joined by or described by a process, that is maybe a constant pressures, that is maybe constant pressure process, that may be constant volume process, that may be isothermal process. So when the state of a system become equal after the succession change of the state during a process, that is the case we told that the system undergoes cycle. So during a process, if the initial and final states are equal, then we say system undergoes a thermodynamic cycle. That we will discuss detail in various cycles later. Now thermodynamic properties are two types, that is extensive, intensive. Intensive properties, extensive properties. Here in intensive properties, these properties basically are independent of mass. So these are independent of mass, and these are dependent on mass. Now let us take some example. Example: pressure, temperature. Here example: volume, energy. So if we can understand this in detail, let us take, this is the our point of area of interest, that is we consider some mass is contained here, mass of gas contained here, so this, they occupied some volume, they have some pressure, some temperature, okay, and they also have some internal energy, that we call that energy, that we'll discuss in later. That is called the internal energy. The internal energy due to the molecular kinetic energy, positions, that is potential energy and vibrational energy, lot of thing, okay. So now if we divide this chamber into four equal parts, and we easily observe one thing is that the pressure in each compartment will be equal, the temperature in each compartment is also equal, but the volume and energy are different of this component, the compartment, the energy may be different than this, and also volume of the earlier system and the now divided system completely different. So that's why this is that's why this is that extensive properties basically mass dependent and this is a mass independent. For the next topic, that is the concept of continuum. Concept of continuum. Here one thing is that in thermodynamic analysis we discussed about the macroscopic, where the effect of the individual molecular behavior is nullified and rather we take the whole behavior of the molecule. Suppose define sign that is area, and this volume contains an amount of mass that is scalar, and this volume consists of, let us say, that 10 molecules, and okay, and one thing is that we can calculate the density rho equal to del m into del p. This is also a property of a volume. This volume is very small, and if the volume becomes very small, then the number of molecules occupied in the volume also will become less. So in that case, the density may be depend on the number of molecules present in this fixed volume. But if we want to disregard the number of molecule, if we want to disregard the effect of the number of molecule on the density calculation, then we have to increase the control volume so that it can contain a large number of molecules. So if there are a large number of molecule present, then the effect of number of molecules on density calculation will be nullified. So this is called, this total concept is called a continuum, means the continuous, means with the help of continuum approach we can assume the thermodynamic properties as a continuous function. Topic, that is that we call a state postulate. So here actually we bring the concept of a pure substance here. Pure substance. A pure substance is one in which that is a homogeneous and invariable chemical composition throughout its mass. Means throughout its mass, its chemical composition homogeneous and invariable. And also for example is that also the example is that steam water mixture, okay, and atmospheric air, but liquid air and mixture of air and liquid air is not a pure substance. Example, atmospheric air. Mixture of water and steam. But one thing is that one catch point is here, that mixture of mixture of air and liquid air is not, this is not a pure substance. So you can give a comment in the video section why this is not a pure substance. So let us now go to the next concept of the state postulate. Now in state postulate, the state of a pure substance can be described or can be fixed by the two independent intensity properties that provided that the system is in equilibrium. The state of the system can be fixed by two independent intensive properties. So while the system is in equilibrium, the equilibrium concept I will discuss in the later in this video. System is in equilibrium, that is thermodynamic equilibrium we can say. Now with the state postulate concept, we can calculate the other properties of the system, other extensive properties maybe, using these two independent extensive properties. Let us discuss about the last topic, that is the concept of thermodynamics equilibrium. Concept of thermodynamics equilibrium. In here a system is said to exist in state of thermal equilibrium if there is no change in the macroscopic properties registered. Now we can say that in isolated system, we can say an example of isolated system that is in course of time will reach to the state of equilibrium. Now how we can say that a system has reached the state of equilibrium? We have three parameters, that is mechanical equilibrium, chemical equilibrium, and thermal equilibrium, that is thermal equilibrium. When these three conditions satisfied for a given system, then we can tell that system is in thermodynamic equilibrium. So now when this mechanical equilibrium condition satisfied, when there is no unbalanced forces present within the system and between the system and surroundings, then the system is reached in mechanical equilibrium. When the chemical equilibrium reach, when there is no chemical reaction taking place within the system and there is no mass diffusion takes place within the system in the different part of the system, then we can say this system is existing chemical equilibrium. In thermal equilibrium, if the system is existing chemical and mechanical equilibrium and the system surrounded by the diathermic wall. Diathermic walls means that is conductive in nature, and there is no change of state there is no change in the independent properties of the state is registered, then the system is exist in the thermal equilibrium. So these are all the basics concept of the basic concept that is need to know in the study of the thermodynamics. Now we can begin our analysis in the later chapters in detailed manner, like the laws of thermodynamics, like a zeroth law of thermodynamics, first law, second law, third law of thermodynamics, and their analysis in detailed manner we will do in the later chapters. Thank you, and give likes in our video and share if you like this, and this will give me some motivation to grow this channel in the future. Thank you.